It's really cool to see so many people turning out here. Look, I got a replica of the couch here and everything. Oh yeah. Look at this, we got a galaxy inside of the studio behind us here, which is pretty neat too. Good to see some familiar faces here. It's super cool. Wow, what a turnout. Well, I'm going to teach you guys about CorridorKey today. Specifically, I'm going to be talking about I'm going to be talking about how it was made, how it works, how I hope it's going to evolve and change, and why it was made, all that kind of stuff. Just going to tell you a story here. So, yeah, green screens. We use a lot of green screens, and I don't like doing green screens. At this point, there's always a little bit of something that goes wrong. One part looks perfect, it makes the other part look bad. You fix the other part that looks bad, it makes the part look perfect, look bad. And it's a headache. And I feel like it should be easier by now. So that was a thing I thought to myself years ago. Started getting into AI, machine learning, seeing the different tools. And I was like, at some point, somebody's going to make something that kind of does the job of green screens, but, with machine learning, and kind of fix this. And a year passes, and, it doesn't get fixed. Another year passes, and you get things like, segment anything, magic mask, rotor brush, great alpha tools, great masking tools, but still nothing that quite does what green screening does, which is to say, you have your foreground subject separated not just from the background with the transparency channel, but also with those green colors unmixed from those semi-transparent pixels, which is a key to making all this stuff work, motion blur, blurry edges, things like hair. All this stuff relies on this ability to kind of separate the green from the foreground. Now, of course, you can do that with professional tools. You can use Delta Key or IBK, like Keylight. You can get there with professional tools, but the whole idea is that becomes a kind of an arduous process of like rotoscoping effectively when you want to make it look really good. And we had this production coming up. We're doing Son of a Dungeon Season 3, Dungeons and Dragons show. And, one of the key concepts of this series is that we play the game, we play a Dungeons and Dragons game, but then we eventually go back after it's edited and refilm scenes cinematically in the world, in the game board that we've, played the game on. And that, of course, requires putting a lot of stuff on a green screen. And I didn't want to sit there and spend, another couple months struggling with green screen keying in the year 2026 when I can talk to my phone, I can have my car drive itself, but why am I still pulling a green screen key in this day and age? And so I had been, waiting for something to come along, and once again, fantastic auto matting tools are coming out, but none of them quite took that extra step for that whole foreground unmixing bit. And eventually, I was like, I'm just gonna give this a shot. I'm not a machine learning guy. I don't have any sort of degree in like advanced neural network training or anything like that. But I'm just going to give it a shot. I'm going to try. And I'm going to sit down with, some large language models and have them hold my hand. I'm going to work through it. And I'm going to ask questions to as many people as I can and just go for it, And so that's how I spent my Christmas of 2025 was sitting there and talking to Gemini a lot. That was my entire plane ride back to Los Angeles from Minnesota was talking with Gemini on my laptop and kind of just working it out and giving a lot of research papers and kind of trying to hone in on an idea of how I was going to do this. And so it kind of came down to a core idea here, which is I can generate synthetic data pretty easily these days. Pretty much we all can, right? You fire up Blender or Houdini or whatever you want, make some sort of procedural system and start rendering out objects on a green screen. And one of the nice things you can do with that is you can get a perfect alpha channel, you can get a perfect foreground separated from the background, you get a perfect background, kick it all out to EXRs, floating point 16, gives you a whole bunch of options here to then do augmentations and stuff like that down the line. So I took that idea, that concept, shoveled that workload off onto the rest of the crew and had them knock out renders, hundreds of renders over the course of about 2 to 3 weeks. And so I had this data set now of, basically 200,000 frames, roughly 500 plus shots. And, the thought was, okay, I have all this put together. I have the data set, garbage in, garbage out, good stuff in, good stuff out. Let's sit down and start training something. So I fired up Microsoft's ImageNet, and did a fine tune on that. And it kind of worked. Kind of looked like garbage. Definitely not good enough to be a professional tool, but it was kind of working and it made me feel really encouraged. So I kept working on it from there. And at this point, I started keeping the results secret from the rest of the gang at Corridor so I could get some good reactions for the video we were making about this. And of course, we have this interesting thing going on at Corridor where we can take a passion project or an idea we have, and we can turn it into a YouTube video to justify us spending the time working on it. And of course, I was like, well, we have this, I'm working on this video here. We're going to make a video about green screen tools, and, maybe we'll get a couple 100,000 views, and, it'll let me justify the 2 months I spent working on this tool to make some of the dungeon easier. And the finale of this video was me doing the big reveal to the guys. And I spent basically the 2 days before rendering these shots out. I barely even got to look at them. I had no idea if they were even going to work, because we went downstairs and we filmed the hardest shots to deal with on a green screen. Jordan Allen drinking from a transparent blue cup and a transparent glass cup with water in them, with transparent clown sheets on his head. Just like the hardest stuff. And I processed it and showed it to them. And one of the gags I wanted to do here, so those shots that you're looking at right there, those shots right there, those are actually keyed out shots using CorridorKey. And I kept that secret from the guys so I could do a nice little reveal here, because I was very surprised at the results I was getting. It was very encouraging. And as you can see, they started to have the same reaction once they saw what was happening here. And there you have it. And so if we keep going here, you'll see some of the other shots as well. Jordan's losing it, Ren's losing it. Because whatever we're seeing here is that, like, hey, maybe I don't have to spend all that time anymore. Maybe there's some hope here, to spend less time doing the technical setup and more time doing the compositing and the framing and the artful stuff, the stuff that you kind of want to be doing. Now, motion blur is a hassle. Like, we always shoot high shutter speed on the green screen. We always shoot deep focus. We try to avoid blurry edges as much as possible, but we're quickly discovering here with some of these tests that that's maybe something we don't have to worry about quite as much anymore. That's it's pretty reassuring when you can get a shot like that. So I was personally really surprised with the fact that this worked, because to me this wasn't just about green screening. This is also about the idea of inventing your own tools as a filmmaker. We're hitting a new era here where you can code. Anybody can code. Anybody can, put together a script. And, for all working with digital media here, like, at some point, I'm sure you've dealt with the fact, like, oh, I've got 1,000 files. I need to do some routine thing too. Or it's like, as an artist, I'm going to go in and just deal with the same rote setup that I have to do every time. And you've probably thought to yourself, oh, it'd be great if somebody made this plugin or somebody made this tool. And, I've had that, dream myself many, many times. So this is kind of me, not just trying to solve green screening, but like, can I make tools now as an artist who's not a computer programmer? Can I stop having to rely on software companies who have to make the paintbrush that I want to use? Can I sit down there and make the paintbrush myself? And the experience was really, really positive and really reassuring, and gives me a lot of, excitement for things that can happen in the future here around any kind of tool that you might want. So I thought it might be interesting to talk a little bit about the technical details of what's going on inside of CorridorKey and how it works. So we're gonna get a little technical dense here, but let's go for it. So what I ended up doing to get those results is I ended up training on a model that Meta trained initially called Hyra. And Hyra is the backbone model that works with segment anything. I don't know if you guys ever use segment anything. It's kind of your classic, put a few dots on the subject you want to keep, and then the AI model will figure out, okay, what's background's foreground. It'll give you a rough mask. At its core, what you're basically dealing with is a system that can look at an image and identify what the pixel is. So, you heard the term chroma key. You can always think of this like a concept key, where it's going to go and identify, is this a pixel of the background? Is it a pixel of an actor? Is it a pixel of a prop? What is it? And little by little, the model gets trained to be like, okay, well, if this is identified as a background pixel, you're going to spit out an alpha channel pixel that's black. It's identified as a foreground pixel, spit out an alpha channel pixel that's white. If it's a fully white pixel, spit out the same original color of that pixel from the input image for the output image. And if it's a semi-transparent pixel, do that unmixing here. And that's where, I relied on the data set to basically train this model how to do physically accurate unmixing. So I had this Hyra model. I had the synthetic data that I made. But you can't just say, here's my, you can't just say, is this working? Oh, this is much better. Now I have something to do with my hands. Okay, so the way this needed to work is I need to teach the computer how to study these images, how to tell if something is working and something is not working. And that was actually the most challenging part of this entire process. Because you end up with this system of losses, of weights, of saying like, hey, if this error is big, minimize this error, but if this error is small, you can ignore it, et cetera, et cetera. So here's an idea of what it took to basically teach the computer how to put all this together. So Christian, if you wouldn't mind opening up one of the debug images here, maybe not the very first one, but like something from halfway through. And these are pretty gigantic images here. And let's go ahead and zoom in to the top left corner here. All right. So the first thing I had to deal with is the fact that, you know, I had a lot of frames. I had 200,000 frames of data, but that's not enough. You need effectively infinite variations. So I did everything from separating the background from the foreground, doing color adjustments to the background, hue, brightness, contrast, gamma, all that kind of stuff. Same thing with the foreground, separately from each other. We gave them, you know, adjustments like aspect ratio, squash them, squish them, things like that. Some, you know, even some mirroring. And that was just the input image. So an input image comes into the system, but now it needs to do some comparisons. So basically what you give this system is you give it two things. You give it an alpha hint, and you give it a just your input image. So your input image would be whatever's on the green screen. Your alpha hint is just a black and white mask saying, hey, this is what I want you to keep. This is what I don't want you to keep. So for example, if you have tracking markers on your green screen that aren't green, you still don't want to keep those even though they're not green. So you can't just say, hey, keep things that aren't green. That's not intelligent enough. So the alpha hint was kind of like my way of saying, hey, if it's not lit up in the alpha channel, right? Even if it's not green, ignore it. And if it is lit up in the alpha channel, even if it is green, keep it. And so it's kind of like that guide, because you know you need a guide as an artist to be able to say like, hey, this is what I want you to kind of hold on to. So after that, the program goes and makes a prediction. It predicts the foreground unmixed from that green screen, and it predicts the alpha channel. Now, I'm sure you guys are familiar with pre-multiplied transparency and straight color. So this is a system that's trained to give you that straight color output, not a pre-multiplied output. The idea there is that you're basically teaching the computer to fully guess the color of that foreground pixel, even if it's only 1% opaque. Because at some point, you're going to need to take that thing, you're going to need to have the background color be removed completely, and tweak the alpha channels, do all this kind of stuff to it. And so that straight color pass is truly the pass that you're going to want for compositing, but that's something that's physically impossible to capture with your camera. But you can use a machine learning model to get it. So, all right. So the program spits out the predicted foreground, the straight color foreground, and it spits out the alpha channel. So now if we go to the top left once again, that's fine right there. So you got these two pictures of the guy. On the left here, we have the ground truth. So inside the training program, it does some compositing. It takes the input foreground, the ground truth, the rendered shot, and it puts it on a random color background. And it does the same thing for the predicted output, puts it on the same random color background. Then it compares the two. Lucky for us, color is a pretty easy thing to define on a computer. Red, green, blue. Values between 0 and 1. Very straightforward, works great for a neural network. Values between 0 and 1 is exactly how a neural network likes to work. So you can do a simple loss comparison where you just subtract one from the other and get the difference. How big is that difference? Well, how far apart are the pixels in terms of their RGB values. So that measurement gets done between these two images. But what if your hue, your color, is off just a little bit on one of those edges? Your RGB values might not be very far apart, even though your hue is noticeably broken. So not only do I do an RGB comparison between these two, but I do what's called a YUV color space comparison. If you're familiar with YUV color space, you basically have your luma channel, your brightness, as Y, and then U and V are your chroma. So you take U and V, and you can just do a subtraction between the ground truth UV and the predicted UV to get your true chroma difference. And you can take that and multiply it to amplify any errors there to make them even more extreme. So, okay, so I got my comp on a random background. The background color changes here for every single image that goes to the system. That way it's unbiased. It will compound any color. It'll learn how to fix any color that's going on there. It's unbiased. But not only is it doing that, if we go a little further here to the side, the same image gets comped onto a neutral gray background with no color whatsoever. So That way it can't cheat and just make the edge pixels purple and be like, I fixed it. Because then the purple would show up here on the side. So same exact comparisons happen, RGB, YUV, and of course the UV part gets multiplied, so any errors there get amplified. So now if we go down, we see the alpha channel. Now, of course, YUV doesn't work for an alpha channel. There's no chroma in it. RGB doesn't even quite work for an alpha channel. It's just one channel, right? So the other thing with an alpha channel is that the inside is all white. And once you've predicted white, your job is done in terms of the computer. And you're not going to get a lot of improvement. Even if an edge pixel is messed up, you're getting a bunch of signal from the rest of this image saying, hey, things are fine. It's supposed to be white. It's white. Don't worry about it. That little pixel on the edge, don't worry about it. But we want those pixels on the edge to be perfect. So I made something called a spatial weighting map. Boom, right there. So basically what I did is I went to the ground truth alpha channel and said, any pixel that is semi-transparent, treat that as an edge. And in fact, dilate that edge a little bit. You know, give me a little highlighted outline using those semi-transparent pixels as your guide. Anything inside of that is considered foreground. Anything outside of that is considered background. And of course, then you have the edge itself. So now I can take that and make a multiplier based on where the pixel is in the image. So if the pixel is in the edge, in that little highlighted white area, you can multiply it. The difference, if you're doing like an RGB minus RGB difference, you can multiply that by 5, by 10, by 20, same with the YUV. So not only can you emphasize just the chroma by doing like a YUV comparison and multiplying the difference between the YUV, you can also do spatial weighting and multiply the difference by where it is in the image. And so I use that spatial weighting to really focus the neural network onto the edges of the image to really make sure that any like differences between the ground truth and the predicted result, we're getting amplified 10-fold, 15-fold, 20-fold if they were on the edge, so that that signal was just as strong as the signal on the center of the image or the outside of there. If we go a little further here, we can see some other visualizations. You have a difference mat between like a predicted output and the ground truth. In fact, let's go all the way to the top right here. Right there, that guy. So this is the ground truth foreground output right there, the render. And this is the predicted ground truth right here. Or sorry, not the predicted ground truth. It's an oxymoron. This is the predicted foreground right there. Now you might notice the background looks all screwy in that. The thing is, it doesn't matter what's going on in this background here, because that never makes it into a final image. That's going to get multiplied against a 0 for the alpha channel, and that's going to give you nothing. So if you try to have a neural network predict what these pixel values should be in the background here, you're effectively entering a divide by 0 type of situation here, where it's going to go crazy trying to predict random noise that doesn't actually affect the output, and you're going to break your model, which I learned after a few weeks of trying to do this. So there's a whole, once again, back to spatial weighting here. I can say, hey, take that background, those background pixels, and ignore them completely. Or, add a little bit of a weight to them if you need to like try to push it down towards black. And that keeps it from breaking the model. So it was this combination of all these different compositing pipelines within the training process that let this program actually give me the result I needed. Because otherwise I ended up with weird situations where, it would give me, the computer effectively learns to cheat, right? If you don't weight it correctly. It might be like, oh, you're trying to, pull the color out of the background. Well, let's just make all the edge pixels magenta. That fixes it, gets rid of the green, right? Problem solved. You're like, well, that's not what I'm trying to do. Or I'd be like, well, let's make all the edges black. Let's just put a black pixel around there because you have a big black background, and with that black background, if I make the edge pixels black, I'm rewarded for it. I did my job. And you're like, well, no, that's not what I'm looking for either. So it was this combination of compositing on a random background color, compositing on gray, doing RGB difference measurements, doing YUV difference measurements, breaking out the chroma part of YUV, multiplying that, breaking out the spatial weights, multiplying based on where it was in the whole process there, changing it as it went through the learning pipeline. You might weigh something heavier at the beginning until it starts to kind of figure it out, and it can ease off that weight and weigh other things differently. And it was almost like making a soup or a stew, but it took like a month to make. So after kind of working this over and over and over and doing process after process after process, honing in little by little on what was working, I ended up getting to a spot where I was getting results that were pretty good. But the challenge is the Hyra backbone, the model that I was fine-tuning, the concept key, if you will. it's just a 512 by 512 image at the end of the day. Anything more than that just doesn't even fit on really any hardware. This is all being trained on an RTX 6000 Pro. I was lucky enough to have one of those machines put together by Puget and NVIDIA. And that let me, really crank this, put out some high quality stuff. And I wasn't worried about optimizing it yet. I wasn't worried about it running on anyone else's computer. I was just worried about it running on my computer. So I got it working, but that, like I said, the higher backbone is only 512 by 512. And if we want this to be professional, you got to be able to see individual hairs, right? It's got to be HD. It's got to be 4K, ideally, right? I want to come at this with no compromises. I want this to work. I want to be able to use this in my pipeline, not just be a tech demo. So what I ended up settling with was I wanted a 2K by 2K image, at least. So I at least had the vertical resolution of a 4K image. And I like to think of it as an anamorphic 4K, right? Just taking the sides and squeezing them in, you got your 2K by 2K image. So in order to get it up to that resolution, there's a second step in this process, which is something called a convolutional neural network, which I actually don't know all that much about. I kind of just said, hey, Gemini, take my hand and then lead me, which didn't work for weeks and weeks and weeks. So I had to learn and do some research and read up on it online. And eventually I got something which I'm still not quite sure exactly the best principles behind it to use, but it's working. And effectively what that does, it looks at your original incoming image, the full res image. It looks at your predicted image, which is 512 by 512, and goes, okay, well, in the full res image, I take this one single pixel of the 512 by 512 and look at the full res image, I see little details in there. So let me put those details back in. It's kind of like an extra smart upres that gets to look at the source footage to cheat and give you the upres version. And once I had that working, once I had the convolutional neural network plus the Hyra backbone fine-tuned, I ended up with CorridorKey. And it worked fantastically, and it blew my mind, and it blew Ren's mind. And I was really proud of it, and it was super cool. But I don't want it to stop there, right? Like, that's about as far as I could take things myself. I also, at a certain point, need to make sure I don't just work on tools, but I also take the time to then use them for the things I wanted to use them for, which if I were to just keep working on this, I wouldn't ever stop and actually work on videos. So this was kind of where I entered the second phase of working on CorridorKey. And that was when I went to release it open source, which has been a fascinating experience. And I should be upfront here, it's technically not true open source, not yet, for a variety of reasons, which I'll explain. But I'm very much figuring it out as I go. And that's been kind of my attitude. I've been trying to be open about that. And everybody's actually been really supportive about that and okay with me like very publicly learning, which can be a little scary sometimes. It's like, here you go. And it's like, oh, it doesn't work. Screw you. So what I did is after I made this, I released the model and the inference code online. I didn't release the training data yet. I haven't released the training program that I made yet. But I basically put it out there. I know we have an audience. We have this fantastic story around it that Austin, one of the editors at Corridor, basically helped put together, which was the YouTube video that you guys saw. And we put it up on our Corridor Discord, Corridor Creates. And, I've never really delved into the world of software licenses and things like that. But I want to try to find a way to be able to release this for free, let people use it however they wanted for free. But I didn't want people to suddenly take it, package it into a plugin and start selling it. I wanted to kind of keep it for free and keep it communal, because the moment people start, grabbing it, and I'm going to put this in a plugin and sell it here, and I'm going to put this in a plugin and sell it here, I'm going to put this in a plugin and sell it here, it fractures this whole concept of people trying to come together and make it better. So by kind of limiting it to be like, hey, you can always use it for free, but it's not commercialized, and you can commercialize it, that kind of focused people to work on it together. And kind of by leading by example, throwing it out there, putting the whole story around it, explaining how it worked, I got a lot of really passionate people that jumped into our community, into our Discord in particular, and really started working on it with me. And the very first thing that happened was, like, when I made this, it required, 24 gigabyte GPU, so 4090, 3090, RTX 6000, like that kind of level stuff. Within a day, people had it running at 6 gigs, which is crazy. One guy who was a graduate student in machine learning came in and he's like, oh, you've initialized the whole dimension that you don't need. So I'll just snip that, and I'll even submit a patch to the official repo there so they can fix it for you. And then another person jumps in like, oh, and your CNN is way too, occupying way too much memory. I can trim that down for you. And somebody else comes in like, oh, you only take that from FP32 to FP16 and, have half the amount of RAM that you need. So within a day, like, people optimize it. It could run on, not anything, but it could run on, normal GPUs. The other thing is I didn't make any sort of graphic interface for this program. It's all, command line stuff. That whole idea was that you drag in a folder full of clips and you wait a couple hours and you get all your clips finished. And once again, it works great for us in our workflow here, but for the vast majority of people, they want an interface, and I totally get it. It makes sense. I like interfaces too. So within 2 days, another user by the name of Ed came in and made a graphic interface and just knocked it out of the park. And because there's this whole community around it that's experimenting and trying things, left and right, he was getting feedback. People are trying different things. People were submitting ideas. People were submitting pull requests. And it was just like a matter of, truly of a couple days until we had like a full-blown graphic interface with tons of optimizations, parallelization, and it went from taking maybe 4 to 5 seconds to render a frame to rendering effectively a frame every second, which is pretty crazy to be able to knock out 1 FPS on something like this. Someone else on the Discord just took it upon, they made it their life's mission to make this as efficient as possible. Like, truly, they built a benchmarking system that in milliseconds defined every single process that this thing went through. And they got it running in real time on a dual 4090 system, which is crazy. First off, crazy they have a dual 4090 system, but but the fact they got it running in real time is bonkers. Not quite practical yet. You're not going to fire it up in OBS and have it keying out your green screens yet. But the experimentation is happening, and it's happening in the open, and people are sharing knowledge around it. And that's been really cool. Where we are at now is I haven't really had the ability to see CorridorKey in use very much yet. I've dropped it basically a month ago. We've started using it a little bit. We haven't actually shot all the green screen stuff for Son of a Dungeon, so I don't have like a deep personal experience with it yet. And kind of the same thing's happening online. People are using it little by little, and I'm getting to see what's working and what's not working. And it's definitely scary releasing something into the world. And like, truly all I tested it on was the shots that you guys saw there in the video with the guys drinking water and, dancing around with clown wigs. I hadn't tested on anything else. I had no idea this was going to work for people. But it did. It was working for people, except it likes to flicker, as you guys probably know. If your footage is noisy, or you have chroma compression or subsampling, you're going to get a little flicker. And that would happen with regular keying tools as well, unless you denoise it. And that was one of the things like, okay, I need to fix that. I need to figure out a way to fix that. And once again, because of this beauty of the community and this kind of communal effort, like, true machine learning professionals have joined in, and they're like, okay, you just need to add these couple things. It will look at the frames before, it'll make them temporally consistent. And there's experiments going on right now that are just completely removing the flicker altogether. And my hope is that, in the next couple months to a year here, we can take this to the point where it becomes a tool that can run on most systems. I don't think it's going to run on any computer, but hopefully it can run on most computers. It's fast and can handle truly whatever you throw at it. Like, that's what I want to achieve with this. And, at this point, the best thing I can do is just encourage other people and give them that energy and give them that support to keep going with it. Because my knowledge of machine learning has been fully tapped out. But my domain knowledge in the world of visual effects has not been tapped out. And my ability to tell a story and to rally people around this idea of, making your own paintbrushes, so to speak. I got plenty of that in me still too. So it's been a really interesting journey so far. It's been really cool experiencing all this, and it makes me really think about what other tools are lying out there waiting for an artist or somebody else to make, because nobody else has made them yet, or a software company hasn't found the value proposition in making it. The ability to just kind of lay out your design, pass it off to Claude or Gemini or whatever, have it come back and give you a plugin. It's a really brand new territory here, and something that I'm really excited about. Like, when I think about AI as a tool, like, It's not specifically like, oh, here's an LLM that does some crazy things, or here's an image diffusion model that does some crazy things. It's, hey, you now as an individual have the tools and the power to sit down and compose a neural network or an AI for whatever it is that you need to do. And yeah, it's going to take some time. There's going to be trial and error and all that kind of stuff. But compute is available for everybody, and there's some crazy things you can do with it. And I don't know what people are going to do with it. I don't know if in 2 years from now we'll have crazy sound tools that can remove the reverb from crappy audio, or tools that will automatically color match every shot, et cetera, et cetera. But I'm really excited to kind of see what people do with this. And of course, it's not just artists, but the actual professional software designers are accelerating as well and doing interesting things. So yeah, it's been a journey and illuminating and really exciting. And I'm hoping to kind of just keep it going as best as I can. So yeah, I think we should take a moment here. And I want to say thank you to NVIDIA Studio for helping with this as well. But I want to ask you guys some questions. I want you guys to ask me some questions. Give me an idea of some stuff you'd like to know. What's next? I just told you, CorridorKey 2.0 with no flickering. Oh, and CorridorKey for blue screens. Well, what I'm really trying to figure out here is, where does the need for a green screen end? And I don't mean in the sense like, oh, green screens are bad, because I actually think green screens are a really handy tool. It's great as a filmmaker to be able to have something that you can say, hey, consider this the background. Like, you need some way to control things, right? You need some way to direct things. If you just say, hey, just guess whatever the foreground is and remove it, well, there's gonna be times when you're filming weird stuff, abstract stuff on a green screen. Like, imagine somebody walking into frame. Sure, when they're in frame, it's like, oh yeah, clearly there's a human being there and AI can pick it up. What about those like couple of frames when it's a blurry blob on the edge of the frame as a person walks into frame? How are you going to dictate, hey, that's a person, not the edge of the green screen, not some shadow that I want to remove. I want to keep that. And to me, the easiest way to do something like that is to be like, just to fall back on your traditional green screening concepts, which is like, hey, if it's green, it's the background. If it's not green, it's the foreground. So to me, something like a green screen is still a really useful tool, but you have issues like bounce light, color contamination. So is there a world where in the future, the ideal screen is like a pastel green screen or a gray screen or a white screen or something like that? Something where it's like, it's a background color that the computer can at least lean back on if it can't figure out what it's looking at, but something that doesn't, contaminate your image colors anymore or your foreground colors. So there's this whole question of like, if you have this kind of keying intelligence, this matting intelligence, how does it affect the physical world of what you're filming and what you're doing? And that's kind of the experiment that we're getting into right now. But before I get into any of that stuff, the very first thing we need to do is finish Son of a Dungeon. Because then I can actually see how it works, and I can learn, and I can tweak things, and the code's right there, and I can adjust it on the fly. So yeah. All right, thanks, Ram. That was a good prompt. Does anybody have any questions? Yes.
So 2 questions. Is there going to be an official 4-door-key OpenFX plugin so you can put it into like picture revolve, something like that? The second one of the other hardest things with green screens is transparent objects. So I know it doesn't do object detection, but could we see potentially a like refraction nav or a distortion nav or like blasts of water or something like that you distort the background?
Okay, good question. All right, so 2 questions here. First one was, is there going to be an official CorridorKey plugin, like an official OFX plugin? Maybe. I know it's not a very good answer to your question. But there is an OFX plugin already. A guy named Ale in Brazil has been working with me, making a runtime C++ tensor RT something OFX plugin, and it works pretty dang good. There's actually a bunch of After Effects plugins that are out as well. I don't know where Nuke is at currently. I don't know where other tools like Baselight are at currently. My hope is that they're in progress and that people are working on them, and I fully encourage it. If there's anything I can do to help encourage that, that's kind of what I'm trying to do here. But the OFX plugin is great. It works really well. You can download it right now for free. It will always be free to download. The second part, what was your second question? I got you invested in the first. Oh yeah, transparency. Okay. So I saw this question a few times on the Discord as well. How do you deal with refraction, right? You've seen it. Somebody has glasses on, and in real life, of course, you can see the background distorted through their glasses when they turn their head to the side. But on a green screen, it just becomes fully transparent, right? It's not how glasses work. It's not how refraction works. Well, at the same time that this whole keying stuff is happening and matte prediction stuff is happening, there are also models out there that are predicting normals, depth, albedo maps, specular maps, things like that. And a lot of what we're doing here is meant for this pipeline. We're going to be using Beeble for the Son of a Dungeon stuff, because that's like a fully built, almost like material prediction pipeline for your footage, where you give it your footage, keyed, ready to go. And it goes, okay, well, I'm going to predict all the normals, how the surface is, where the surface is facing. I'm going to predict, what's the colors there without any shadows or lighting on them. I'm going to predict how shiny things are. And with that, then you can throw it right into a program like Unreal Engine, and you can relight your real footage in Unreal Engine or Blender or whatever, any program, right? Any 3D rendering program. And my thought when it comes to transparency, as long as you predict the transparency correctly and you subtract that background color so you don't have like a green tint in your glasses, in order to get refraction, then you have to lean on your normal prediction. What's the curvature of that surface? I did see a really fascinating idea somebody had, which was to make another synthetic data set with UVs, basically UVs mapped out as another output, so you can train the program to predict what the UVs are for the things that you're looking at, which is a crazy concept. But once again, as this stuff gets out there, and my plan is to release the training data and the training program, which once again, it's a vibe coded, hobby fest. Like, it's probably not that great, but at least it can start, right? Once that's out there, somebody else will be like, oh, well, let me just render out these passes instead, hit go, wait a few days and end up with a model that's trained to predict a different kind of output, but running out the same structure. And of course, if somebody else comes out with a different backbone model to try, or a way to train a model from scratch, ideally, because this is open and in the community, people can kind of jump in and do this kind of stuff. So I would encourage you to give it a shot, honestly. It's maybe like my plan is to release the training data and the training program once there's a good plugin for every program. So I figured, it's one thing to have the model, it's one thing to have the inference ability, it's another thing to have the tool. And that's a big thing I realized. Like, cool, I finished it, it works great, and I release it, and people are like, oh, this is like a command line interface that requires 24 gigabytes of VRAM. This is useless. It was like, yeah, they're right. I need to be able to actually just use it in the program that I use. Everybody needs to be able to use it in the program that they use. So once you can fire up After Effects, DaVinci Resolve, Fusion, Nuke, etc., it's download for free, or it's there or whatever, and you can just use it. Once it's that easy, then I'm like, okay, put the training data out there, put the training program out there, let people go to town. At least it's been centralized, it's been demonstrated. There's a focal point for when people train new models or new ideas. There's an architecture on how can they get utilized in software, which is a whole second step from the first step of just train it in the first place. So that's where that's at. All right, I'll take another question. Yes.
Load your test key. Did you consider using perhaps a dark grays or a black that blackground?
Cool. Well, thank you. So his question was, what do you think about doing like a dark gray or a black background? Something I thought about. It comes down to being able to cue in the computer as to what you want to keep as foreground and background. Let's say you're filming a miniature exploding and a bunch of tiny little black particles go flying off into the air. How do you know that those aren't tracking markers? How do you know that those aren't background, right? So I think there is a certain point, as a person filming, as a filmmaker, you still need to step up and help the computer a little bit. And that's where I think, at the very least, a light gray might be the way to go, so you still get your bounce light, but it's not contaminated with the color. Or you go with the hue, a touch of magenta or tan or green or something like that, so that worst comes to worst, you can still just fall back into a key. And that's one of the things I like about filming on a green screen, is I can still use color keying, right? Like, color key tools still exist, and they're not bad. Like, they're pretty great. It's just that this is one click, close to one click. And that's the idea, this gets you there quickly and painlessly as much as possible. That's the goal. So I don't quite know what the end result will be, and frankly, my hope is that, once again, people experiment, right? It's just a matter of kind of setting up your computer to kick out some renders for a while, and then setting up the training program to chunk on those renders for a while, and then you'll have a different model. You could train a gray model, you could train an orange background model, you can train a blue model, etc. So, yeah.
You mentioned Gemini a couple times. Is there a reason Gemini was your go-to?
Good question. All right, so I did mention Gemini a couple times, and I'm sure everybody's like, well, why aren't you using Claude? It's because Gemini is cheap. For $20 a month, I can basically get unlimited Gemini, and I don't get unlimited Claude. The other thing is that the challenge here wasn't so much the programming. It was the design. And frankly, you need to be able to write the entire program in plain English to the exact details of how the compositing formulas work. Once you can do that, you can throw it in almost any LLM. It doesn't need to be Claude, and it'll get the job done. And that's basically what I needed to do here. The other thing I learned is that, LLMs, they're great at taking structured language and turning it into, script, code, etc. They're great reasoning logic machines. They don't understand images whatsoever. So when I'm comping an image, it doesn't know what pre-multiplied is, or straight, or linear, or sRGB versus 2.2, like gamut, like all these things are, even though it thinks it knows, it doesn't know them. And constantly I was dealing with issues where, because I had to do basic code, a compositing pipeline for this, for all the testing that the loss and the weights go through as this model is trained. And so I had to program in like, okay, let's take in this sRGB EXR file, let's convert it to linear, let's unpre-multiply it, let's comp it on this background, and then we go through it like, oh, it's using the pre-multiplied compositing formula, not the straight color compositing formula. So little by little, you go and you find these little problems, and you have to lay it all out there. And maybe in the future, the highest end LLMs will catch that kind of stuff. But my experience has been that you really have to bring your domain knowledge, and then the LLM like Gemini will do the coding. And at that point, Gemini was completely capable for what I was, what I was needing. Yeah. All right. Any other questions? Nice corridor hat.
In your research heavy kind of now, like, how does it work? It's like background objects, right? Some make screen utility peppers, rates. I'm answer. There's a lot of white background. It is interesting to see like
Yeah, good question. Okay. So the question was, how do you deal with things like background objects, like a light, a stand, the edge of the green screen? So that's where something called the alpha hint comes into play. So my thought was, rather than having the program completely guess what the foreground and the background is supposed to be, once again, if you're an artist, you're a filmmaker, you can at least give it a hint, right? AKA an alpha hint. You can pull a green screen key and just be like, this is the background, this is the foreground. Here's a black and white image that shows that. Or you can do a magic mask or a roto brush pass or whatever. Like, it doesn't need to be good. Just a way to be like, hey, if it's white pixels, it's a foreground object. If it's black pixels, it's a background object, even if it's not green. And it really comes down to control. Like, you need a way to control your shots. Like, you can't just be like, AI, take the wheel, help me. Like, you got to have a way to tell it what you want to keep. And so that's why I rely on this whole alpha hint concept where, pull a quick key. It doesn't matter. Or use magic mask. But just be like, I want this. I don't want that. And then the model ideally is intelligent enough to divide it from there. Because the actual separation of foreground from background isn't happening through a chroma process. The chroma really only comes into play when it's that unmixing on those semi-transparent edges. There's also this concept of like not reinventing the wheel. There are research projects out there that are so good at alpha extraction, like amazing, immaculate alpha extraction. There's research projects out there that do so many different things. I didn't want to have to reinvent that. I just wanted to really focus on the whole unmixing side of things and just making it usable one click or as close to one click as possible for our workflow, and then go from there. Yeah.
Weird question. How do you think you would handle retroactive compositing?
Retroreflective compositing. They probably handle it fine, honestly. Yeah, it's I think you probably handle it. I'm very surprised at how capable this system is at pulling the foreground from the background, whatever the background might be. But just as long as it's like a flat wash of color, it could be anything. Yeah, but it's also one of those things where I don't know until people try it, and it's only going to get better if people try it and kind of give feedback to each other. So yeah.
With dealing with things that are out of focus, I keep on the background. What? Say it up to shoulder shot. We go to challenge this. Because they're talking to each other. Do you think you'll be able to deal with that sort of mouse string with this stuff, or is that like it's gonna?
Okay, so the question was, how do you when dealing with really out of focus stuff, like an over the shoulder shot, right? Over the shoulder, 2.3 or something like that, you know? It gets really blurry. It handles it pretty well, actually, currently. I really made sure that the data set that I was feeding it contained extremely blurry shots, extremely motion blurred shots, fine hairs, other crazy kind of things like that. Like, I basically made sure that there's a render that documented every single problem I've had to deal with over my 20 plus years of compositing stuff. So that as long as I can handle it in the data, I knew I can handle it in real life, and it generally does. I mean, if you go really extreme and you have a gradient across the entire frame of opacity, yeah, you still gotta like try a little bit to like treat your green screen with respect. But it handles it pretty well, and I think that's a sign of it working how it should. To me, the stress test I would do is I'd throw like really transparent smoke at it. Wispy smoke elements, things that are already keyed. I'd recomposite them on green so I'd have that ground truth still. I'd just see how well it could do, and it did a pretty dang good job. Yeah. Yeah. All right, any other questions? All right, well, I guess I answered them all. Okay, yes.
I'm wondering, are there any looking cores making it almost in real time plugin?
Yeah, so the real time is tricky with machine learning stuff. A big thing I've learned with this is that getting a machine learning model, a neural network, to run on your computer the correct way is really challenging. By default, your computer likes to run things as a single thread on the CPU and call it a day, which is fine if you're just gonna, change some folder names or do some basic math. But if you're going to run, long matrix multiplication and try to fire it on all 1,000 of your CUDA cores or something like that, you need to be able to talk to your hardware in a really specific way. And that's been a bit of a challenge. There's definitely tools for it. Like, if you're set up correctly, you have the proper, most recent drivers, you have the proper PyTorch, et cetera, et cetera. Like, you can make stuff sing. The problem is that a lot of people, there's a technical barrier between just installing a program and then making sure that you have all the proper necessary drivers and dependencies and, I guess, triggers and flags to really make things work correctly on your GPU. And we're also kind of in an era where that hardware has been kind of rapidly evolving over the past couple of years. Like, you go back to hardware older than 4 or 5 years from, ago, like 2020 and earlier, and you start to really lose the abilities to put the stuff through a network fast. And at this point, I can just kind of, just put it out there and hope that people will work together to solve those things with that hardware. Have any of you guys used CorridorKey? Has anybody experimented with it? What was your experience like? Good? Okay, that's good. What kind of shot were you keying?
Just a basic green screen stuff. I used Blender a lot, so I made a lot of shots with blurred backgrounds, smoke, and it was very impressive.
Okay, I'm glad to hear it worked for you. What kind of system were you using?
I have a 20 or 3050.
3050?
I'm 3050. I had 3070.
Okay.
I ran it on both, but I also have a 1080 that
Works on a 1080 too.
was fine. It took a while, but
Okay.
yeah, it worked.
Yeah, like the next steps for me, besides just trying to make the plugin better and foster that community development, is also try to just make sure that, like, I'm learning a lot about software licensing in this process. Like, right now it's under like a Creative Commons license that protects against non-commercial, but I'm learning that Creative Commons doesn't really apply to code and yada yada. So just little by little, day by day, talking to people, and they're guiding me through it. But at the end of the day, as long as people are kind of coming together into a central point and I can like maintain their energy, I feel like we can make it happen, right? We can make green screens easy. I feel like somebody would have done this 6 years ago, but at least it's happening now. Yeah. Let me see which song I got left. That's kind of everything. We got a few more minutes. Yeah, I guess anything else? Any other questions? Anything that people want to know? We got one in the back there, yes.
So, what is the advantage of green screen over sodium vapor?
Oh, good question.
Why wasn't sodium vapor an option if you're paying for some?
Gotcha. Okay. You guys familiar with the sodium vapor process? The most mathematically precise way to pull a mat these days. So the question was, why aren't we using sodium vapor? Sodium vapor is very cool, but it's very specific for how it can be used. A couple of challenges. One, because we don't have the magical Disney prism that has the split in the middle of the splitting wavelengths of light, we have to take our light, split it first, and then filter it. What that means is that every exposure is getting half the light it would otherwise. So you start really having to blast your set with light. The other challenge is it's a rig with 2 cameras, so the challenges of shooting stereoscopic apply to shooting sodium vapor, which is to say you have to have 2 cameras perfectly lined up, same focal length. If you're going to pull focus, you have to pull focus across both cameras simultaneously. If you're going to zoom, you have to zoom across both cameras simultaneously. So there's definitely restrictions with sodium vapor. The thing that I haven't done that would be interesting to try is to make a data set using sodium vapor. Take the time, set it up, put it on a tripod, put it in the background. You're not going to pull in focus, whatever. Make life easy, right? Take that, record real life footage, get a bunch of different stuff, and then you have your perfect alpha channel mask, you have your perfectly unmixed foreground, etc. That would be a really interesting way to use sodium vapor. But I think using sodium vapor in real life is really relegated to very specific setups where you're not pulling focus, you're not pulling zooms. Camera could move, but you're going to be dealing with a lot of hardware there. Some ideas that people had mentioned back when I made the sodium vapor video with Paul here was using sodium vapor for the backgrounds of sets like when you're in like a skyscraper apartment set or anything else like a lot of reflection in glass and that kind of stuff. Things that would be tough for green, but aren't so bad when you have like a perfectly physically filtered system that's giving you that kind of perfect wavelength of light. That's a good question. Sodium vapor is really cool, and it's like our touch point for like the ground truth. Like if we can hit that quality, then we're good. We're not quite there yet, not even with CorridorKey. It's still not quite as good as sodium vapor, but it's way easier to set up. Yeah. All right. Any other questions? Yeah.
I vibe coded before.
Uh-huh.
And hit a lot of roadblocks.
Uh-huh.
What were the things you learned along the way? I tried doing like a non-linear editor and just troubleshooting bugs, all that kind of stuff.
Yeah.
Very, very hard.
So when it comes to vibe coding, Niko's vibe coding tips. All right, 5 minutes of Niko's vibe coding tips. I'm by no means a professional, but I quite enjoy doing it. Make sure you're using an intelligent like IDE, like Cursor or anti-gravity. I use anti-gravity personally. It makes your life way easier. You're not just deal with copy and pasting and chunks of code and all that kind of stuff. The other thing is to really make sure you take your time to plan and to write out your plan, whether it's by yourself or with an LLM. It could be separate. It doesn't need to be in your coding environment, but plan everything out. Another really important thing to do is to look up previous research, find other papers that have been published that deal with the same problem. Read up on them. If there's something that you don't understand, take the time to understand it, whether it's, Claude, what does this mean? Explain it like I'm 5, or whatever. It doesn't matter. Just try to wrap your head around it. I'm a big believer that even the most sophisticated advanced concepts can be understood if they're phrased the right way by almost anybody, and you have like the right foundation, the right nuance to get there. I guess I would say the other thing was just, building it modular. Don't try to do everything at once. Build it piece by piece. Don't let the LLM go to town on your entire code base. It's going to screw things up. It doesn't have that awareness. You really have to think of it almost like a translator. You're writing the book. The translator will get it into the appropriate, language for you. But if you're not writing the book, the translator can't sit there and just invent the story points for you. So that's how I'd say, the pitfalls, the things to think about, to look out for. One really cool thing is that as your program is being made, if the LLM does something that you don't understand, take the time to say, hey, explain to me what you did, and walk through it from there as well. So it's really, really important that you steer the ship. And it's really easy to not steer the ship, but that's when things will fall apart. Yeah. Okay. Anybody else? It's really, yes.
Inspiration. I don't know too much about that, but I understand there's pop up like Steve said, give me up that process it. But wait, Steve, tell us a little bit about that.
Yeah, okay. So the question was to talk a little bit about the Beeble integration here in the process there. So Beeble, it's a funny name, is a AI piece of software that will take your footage. You can do an AI roto on it. It will predict normals, it will predict albedo, specular, etc. And then it also offers a very kind of fast pipeline to put that into some 3D software package of your choice. One of the really interesting things about it is the compositing aspect of visual effects kind of gets blended with your 3D layout and rendering side of your pipeline. And it's kind of a change up in a really magnificent way. Let's say you're going to be doing a shot in Unreal Engine, walking down the dungeon halls, right? You got torches burning and you got dungeon steam. I don't know, and a skeleton in front of you or something. Dungeon steam. Those are things that you'd have to deal with compositing in layers. Like either going to deal with like, you know, depth compositing, or you're going to deal with just, you know, rendering all your assets. You can pop them into whatever compositing program you're in, stick things on top of each other, tweak the color levels, get the bloom right, etc., etc. But now if your footage of your actor lives in the 3D scene and has normals, so it's lit by that scene, and it has the proper specular and highlights and that kind of stuff, and it's motion tracked. Well, now when you render out the scene, you're rendering out one unified image where all those elements are being comped in that scene as it's rendered, you know, physically based. And it's, you know, any lens effects are happening to the entire scene as one full stack. And so it skips over some of this chunkiness that happens when you kind of have to like fake things all being in one composition versus just being in one actual composition. So we're really excited about that, because when it comes to this D&D show, you know, the idea is that we're going to be literally in the game board that we filmed on. You know, the whole game board is built in 3D. It was 3D printed and painted, but we still have the 3D file. So we played this game, but now we can be in the actual game board at the same time. And, you know, if you're dealing with Dungeons & Dragons, you're dealing with many, many minutes of footage. So, you know, film your actors in the green screen once, take a 2-minute shot, bring it to life in that world, skip the compositing step, just everything's in Unreal Engine or everything's in Blender, and just hit render and you're done. So that's the whole idea here. You can kind of see some examples there of, you know, the older versions of Son of a Dungeon. Yeah. So that's kind of where things are at, and it's really exciting. You know, it's cool to see the turnout here, you know, for learning about CorridorKey and talking about it. There's something really fulfilling about making a tool and then people actually finding use from that tool. It's a very good feeling, hard to describe. So I'm really, really happy with that, and it's really energizing and keeps me wanting to go and make more stuff. So yeah, thank you to everybody for coming out and joining us here. It's super cool to see everybody. It's good to be back at NAB.